Okay, I discovered that I made a slight grammatical error in calculating the Planck's constant, and I didn't notice because the b value was so small that it still came up with the same value. But anyway, now the calculation is the radius of the hydrogen atom divided by n, and that's the magnetic vector potential, by the way. And then I put in the radius. That's actually level 2. Doesn't make any difference. Let's say which level I choose. See here, here's the charge at level 2, and at level 1 the charge is still the same. So is the Planck's constant. It doesn't vary with the level. See? So anyway, let's just make it 2. And the reason is the magnetic vector potential doesn't change for the entire periodic table. In other words, for all of chemistry. So at level 2 you've got a voltage of negative 3.4. The charge doesn't change. Planck's constant doesn't change. Now notice now that I've separated the relativistic slide rule from the man-made units in brackets. Charge turns out to be b squared, which is the same as the gravitational potential. And Planck's constant turns out to be exactly b to the power of 4. See, before my mistake was I was sticking in, I thought I just made a grammatical error, and I thought I needed that L in there, but I didn't. And when I up the b value, the error becomes obvious. So I fixed that. So it's yeah, that's v squared for charge, v to the power of 4 for Planck's constant now. And this is normally how you can calculate it at home, just using diffraction in a laser light. What you do is you multiply the voltage of the laser and the wavelength of the laser by the charge, and then divide by the speed of light, and that A has got to be in there because we're talking about fermions, because I'm actually doing the calculation for an atom. But you get the right answer. And electron mass is also b to the power of 4. So in other words, Planck's constant and electron and mass. That's why they're now saying Planck's constant is a basic unit rather than mass, because they're both b to the power of 4. And this is confusing, I don't know, but if I try to calculate a proton mass for the hydrogen atom, it's slightly light, but if that was right, it would be b cubed. And the Bohr magneton is b squared as well, once you separate out your units. And then I haven't solved the problem of this anomalous magnetic moment. It's about 0.50057. I was hoping it would be my fixed kinetic factor, but that actually starts blowing up at that really low b value to 0.73, which is too high. So that's the radius of the second level. That's why I've chosen second level, because you can see the total split is correct there, and you got a up split and you got a down split, and that's all correct. Also put in the electron standing wave based on the Zitterbewegung, which I think Schrödinger calculated from Dirac's equation. And when I calculate it, everything simplifies, and I end up just with totally man-made units. It's you could say it's a constant. It's got nothing to do with the slide rule. Slide rule would just say it's 1. And of course our frequency is a constant, so I don't know. Anyway, that's the simplest way to calculate it, rather than the other way, which I think is 2 times the mass times speed of light squared over Planck's constant or something. Yep, cancels. Anyway, also, obviously this B value is nowhere in physics. So what the hell? What am I doing there? Where does that come from? Well, notice that if you take the fine structure constant, divide it by that magnetic vector potential, which I'm choosing, and then if you square it, no, wait a minute, what's going on here? Oh, sorry, capital B. I started using the capital B slide rule. You get this, and that's actually the difference between charge and the mass of the electron. And notice that therefore if I get the charge of the that's the charge of the electron, and multiply it by B squared, I get that value. And if I grab the mass of the electron, and I'm having to use an h because I've already used little m, and multiply that by the fine structure constant squared, I get the same value. Notice they equal each other, and it just so happens that they both equal about 3 times the Planck length. Not exactly, not precisely, but, and I don't know why, but so definitely this that is key. In fact, that's key to all of chemistry. That's the value, and I don't know why it doesn't appear in physics, but anyway. Okay, now on to the wave function. So, wave function collapse. Let's say that I don't know, got an electron whizzing along at 0.4 C or something. And it's first to hit. It hits the screen. Double slit experiment, let's say. It's the first, so it takes all paths, and so the path of least time is the one that absorbs all the others. And I've modified my Schrödinger's equation so that you just with that little b squared really, so that that distance between there and there is actually b, and then if you square it, you get this, which is the intensity of reflected light, actually, because if that was a surface and a photon was hitting it, this would be reflected and that would be transmitted. It all works out anyway. The calculations, the angles and everything. But I found that if I put a little b squared, then it equals the magnitude, the amplitude of it equals little b squared. And so I'm sort of, I mean, I could take the modulus and square it, which is what normally has to be done, so that you go, oh yeah, the photon went through both slits, and there's a probability that it went through one, and the same probability it went through the other, and then it collapses to one of them, sort of thing. But I don't really need to square the modulus, because I can just say that what's it called? The Bohm-Aharonov Bohmian mechanics. I'd say the photon actually only goes through one, and because the relativistic slide rule is relativistic, I don't have to worry about making it relativistic. It's already relativistic, and on top of that, I don't have to worry about the particle reacting against the field, because it's all of its properties are in the field. So its inertia and its mass and everything is actually just part of the field. So it's a point particle. It doesn't have any resistance. It is completely just part of the wave function. Just so yeah. So oh crap. So I don't need to really squaring the modulus. I can just use the good old Schrodinger's wave function, and then just collapse it. So let's say it all collapses like that. Everything just collapses to the path of least time, and there's the 100% probability of finding the electron is there. Back to point 4. I can't remember if I actually mentioned that I put the holographic principle in undistorted from Gabor's original paper, and I found that I had to use 0.4, which is, I think, the speed that electrons go through the double slit experiment anyway. So there's somebody observing the screen and seeing the electron collapse. Well,